anyone who turns up can just catch up. Right, so we're finishing off today 15.2 because that's all we need for this week. A fair amount to do. Oh, perfect, someone turned up now. The stuff I called puzzles last day basically break into three questions, types of questions. We're going to look at an example of finding the volume under a plane, which is this one. And we're going to look at some questions where you've got a double integral, but we're going to change the order. So instead of the x as a function of y and from a to b and then y from 0 to 2, we're going to switch that around. That's quite visual, how you do that. And then we're going to do a guy called the average value of a function, which is closely connected to Calc 2, finding the average value of a function. So let's look at the first one. How do you find the volume under a plane? A plane is a very specific thing. It's a flat piece of paper. So here is my plane, here. Here is the x, y, z axis, and we are going to find what they describe as the volume under the plane. Basically, you think of the xy plane as being the floor, and then the plane comes down and cuts it. And our job is to find the volume that that shape makes based on this equation and how it interacts with the x, y, and z planes. So here's the shopping list for doing it. The first thing you need to do is find the x, y, and z intercepts. I kind of touched on that last time, so I'll do it again. I have an equation 8x plus 2y take away 4z equals 12. Now, if I want to find out where it cuts the x-axis, called the x-intercept. Oh, by the way, when we're finished this, won't it look like one of those ugly pyramid things that we did last time, right? Like the four-sided dice. That's kind of what happens when a plane hits the XYZ axis. So to get the x-intercept, you basically make y0 and z0. And if you do that, you now have 8x plus nothing, take away nothing, equals 12. And so that gives me an x of 3/2. So if you imagine that that point there is at 3/2. Now, if you want to get the y-intercept, you make the x 0 and you make z 0. In this case, you get 0 plus 2y, take away 0 is 12, and you get y equals 6. So we'll pretend that scale doesn't matter, and that can be 6. And finally, you get the z-intercept. And you get that by making the x 0 and the y 0. In this case, that's nothing plus nothing, take away 4z equals 12. And so that makes z equal to -3. So technically speaking, our guy is down here. Now, if you want to imagine what this shape looks like, if you join these two guys up like this, I'll shade it. I'm not sure if that's going to help any, but can you imagine this is sloping below the XY plane, something like this? And so we're trying to build, as best we can at least, what this would look like. And I just forgot to join something correctly. Should have been there. That's a much better answer. So it's basically a four-sided dice. If I'd got one that was above the axis, it would have looked much easier. Can you imagine it was that guy? You see the little triangular guy? Orientation is making that hard to see, but it still exists. So that's the first thing you do. You find the x, y, and z intercepts. The second thing you're going to do is to find the triangle in the xy plane, because that's what it's going to make. Now, if I just reorientate the floor, and it looks like this, I know that this particular shape is going to cross the x-axis at 3/2, and it's going to cross the y-axis at 6. And this guy is what the triangle on the floor would look like. That is our D. Now we have to figure out how to basically write this down as the bounds for X and Y. I'm going to go for no particular reason, except I like to go this orientation. I'm going to be scanning vertical lines from left to right. And we're going to assume that that's 0, which it is. That tells me that the X's are going to start at 3/2 and 0, right? So that's the X bounds. The Y bounds are going to be at 0, which is here. Y equals 0. And then to get this guy, don't I need to know what Y is in terms of X? In other words, I need to know the equation of this line. And I want to do it as quick as I can. So if you look at the rise of this line, it's 6. And if you look at the run, it's 3/2. So that's 12/3. So that's 4, and it's sloping downwards. So it's -4. So I know it's -4x, and it crosses there at 6. So can you trust me that the equation of that line is 6, because that's the y-intercept, and this slope, rise over run, gives me a slope of -4 because it's pointing down the way. Well, that's it. We've got our double integral. We're going to do x goes from 0 to 3/2. This is going to be step 3 now. Y is going to go from 0 to -4x add 6. And here we should do the function f of xy. So what you're going to have to do is you're going to have to rearrange this so that it becomes z equals. Probably the easiest way to do it would be that way, and then divide everybody by 4. So 2x, 1/2 y, take away 3, and that should say z there. That is him. So we have a 2x plus 1/2 y, take away 3, and then we do dy dx. Are you comfortable about finding the x, y, and z intercepts so you can get a kind of idea of what the 3D shape looks like? Not great in this situation. More importantly, find out where it cuts the x and y axis so you can find the triangle. In this case, that one. And then find the limits of integration using your picture. In this case, I went vertical, so 0 to 3/2, and then the y goes from the bottom, which is 0, to there, which happens to be the straight line, -4x add 6. And then you put your limits of integration. And at this point, I'm just going to say ... I think we've done enough of those double integrals. Yes, Sally, the question.
I was gonna ask, so I know that there's like you do horizontal and vertical rectangles. I was wondering if there's like a specific like way to know when to use one or another, or if it's just however
they both work.
Whatever you feel like.
Whatever you feel like. Now you can try both, and if the numbers are nicer, then you should use it. So in this case, I get -4x add 6. Would you agree that's quite nice numbers to work with? Right? Nice numbers. Now, if I decided to do it the other way, in other words, scan horizontally, I would be saying y would go from 0 to 6, which is fine. And what would x look like? Well, x would be 0 to this straight line. But if you rearrange this straight line, you get, what do you get? You get -1/4 y plus 3/2. And that would also work. And you'd get 2 different ways of setting up how to generate that region D. Would you agree this one's just a little bit uglier because of the numbers? Would
Yeah.
No, it wouldn't be wrong. You get the right answer. So in a way, that's kind of nice, isn't it? That in this particular planes meeting the floor, you always get triangles from planes meet floors unless they're parallel to the floor, which is a silly question then. And so you're basically going to have a straight line, and straight lines are relatively easy to calculate the equations for. Any other questions? It's a good one. So if I gave you a plane like this, and I asked you to find the area under the plane, essentially find this guy. I prefer it when they're above the thing. I can see it better, but whatever. Are we good? Right. So the next thing in my list, because there were 3 of them, is changing the order of integration. So let me tell you where those questions are. So you're going to find them in question 13, question 14 in your homework, 15 as well, and any more? Right, so these are 3 examples of changing the order of integration. So imagine that you have been given, which shall I pick? Yeah, this one will work. Imagine that you've been given the integral from 1 to 5, and the integral, that's from x equals 1 to x equals 5, and the integral y equals 0 to y equals log x, and the function f of xy. So they're not even telling you what the function is. They want you to reverse the order. You're not allowed to do this. Well, I just make y equals 0, y equals log x, and I make x equals 1, x equals 5, and then I just write this guy, and I switch the x's and the y's. Why is that not going to get you any reasonable answer, no matter what function f of xy is? Why is that the wrong way to do this?
Because then you would end up with equation instead of just getting a number, regardless of how ugly said number is.
If you did this one, wouldn't you probably get some expression with log x's in it, typically? And shouldn't a double integral of these type always be a number? Because don't they just represent a volume, right? A physical thing that exists in 3D space and therefore has a volume. So you're not allowed to do it. Now you are allowed to do it, of course, if you had this situation. In this second situation, isn't it okay, and sometimes it can even be useful, to switch the order? Haven't we talked about as long as everybody's a number, isn't it okay to switch the order? But if there's a variable anywhere in the limits integration, and if there is going to be one, it has to be in the first one, you are not allowed to just basically switch them. So that means this is a little bit trickier than it originally looked like. So what do we know? Well, according to here, we know that x is between 1 and 5. And according to these, we know that y is between 0 and the natural log of x. So the first thing you should do is to draw this region D. Well, I'm going to put in y equals log x. You see it? Looks something like that. And y starts at 0, which is the x-axis, right? And it goes to that curve. And x starts at 1 and finishes at 5, right? And y goes from 0 to that curve. Can you now see what the region D looks like? Can you see how I created the region D by using the limits of integration? Rosie, question.
On the left side paper with the correct example, where is the natural log of x in the limits of integration?
Here, I don't think that's your question. But,
Oh, because you went through the incorrect way to do it.
yeah, and I am now going to do the correct way to do this.
Oh, okay.
Now, are you comfortable about the 0 to log x and the 1 to 5 when you put them together generates this guy? Now, when they say switch the or change the order of integration, right now, the way this has been done, because of these numbers, isn't this a vertical rectangle scanning horizontally like this from 1 to 5? Do you see it going? Now, what I'm going to try and do here is to do that same region, this guy here, but scan it horizontally. Now, if you're scanning this thing horizontally, the limits of integration do become different. In fact, this guy here is a natural log of 5, and this guy here is obviously 0. So let's see if we can make this region work with horizontal lines. So if you scan from the bottom to the top, you're going to do y values from 0 to log 5. Are you comfortable with that? At the bottom, right, y is 0, and as you scan to the end of the shape, won't y be log 5? Now, what about the x? Well, this formula or this function is called y equals log x. But if you rearrange this formula, isn't it also x equals e to the y? Are you happy about the transformation? Now, that means that this shape goes from 5 to there. Right? From 5 to there. Would you agree every horizontal strip isn't the biggest value of x5 and the smaller one, the guy on the curve? And the curve is x equals e to the y. Now you put those together, you can now change the order of integration. It's going to be y equals 0 to log 5, and it's going to be x equals e to the y to x equals 5 of whatever the function happens to be. Do the x's and then do the y's. And we have now changed the order of integration. So to be able to do this, don't we have to be able to change the equation of the curve from y as a function of x to x as a function of y? We had to be able to do that switch. And you might think, well, why would changing the order of integration be a useful skill? Some double integrals are really ugly if you do them one way, and are really nice looking if you switch the order and you do them differently. So here is a version of question 14. Going to change the order of integration. From this version into the other. Well, let's imagine that I tried to do this integration in the order that it's written. Won't I have to integrate 7e to the power of x squared with respect to x? Agreed? Right? If I do it in that order. Does anybody here even know what the integral of 7e to the x squared is? And the answer is no, I don't know what it is. Well, I guess I could figure it out.
I mean, it could be one where the forms in a table of integrals, but
yeah, it'd be really horrible.
The math extremely messy.
Right. So would you agree there's a good reason why you don't want to do it in that order? Right. We're trying to sell you the idea why this could be helpful. Right. So I'm now going to take these limits of integration and create what the region D should look like. Now, x equals 12 is basically, is here. And x equals 3y is the same as y equals 1/3 x. That's the same thing as x equals 3y, right? And so from 1 to 12, and y goes from 0, which is here. And what is 4? Well, by sheer coincidence, that happens to be 4. So it's not a surprise. There isn't that limits of integration generating a triangle. Are you comfortable how I took this information and created the region D? Now, right now, because y equals 0 to y equals 4, aren't they doing horizontal rectangles, right? Y equals 0 to y equals 4. And we know that that's not good. So what I'm going to do is make it a vertical rectangle, right? And scan through it from here to here. Now, if you scan from here to here, don't the x's go from 0 to 12, right? And what do the y's do? Well, at the bottom, they're 0. And at the top, aren't the y's the straight line 1/3 x? So we now have the integral from x equals 0 to x equals 12, the integral of y equals 0 to y equals 1/3 x, 7e to the x squared dy dx, right? That's the change in order. Okay, I'll pause for a minute. Are we comfortable about how this double integral get converted to this new one by creating the region D and scanning it the opposite way? We good with that? Right, now let's do this integral, because the first way was downright impossible or extremely ugly. Although this one might not be perfect, at least it's better. Well, if you integrate 7e to the x squared with respect to y, don't you just get 7y e to the x squared, evaluated at 0 and at 1/3 x? And then you do the x equals 0 to x equals 12 guy. You plug in 1/3 x and you get 7 times 1/3 x. That's this guy. Take away nothing. Would you agree that you can do that integral? What method would you use to integrate 7/3 x e to the power of x squared?
Our good old friend integration by parts.
Not this time. It looks.
It's a U sub, isn't it?
It's a U sub. And if it is a U sub,
Okay, that's a lot nicer.
it's an x squared. Now, the reason why integration by parts doesn't work, wouldn't you have problems with an f and a g? Because no matter which one you pick, wouldn't you have to either integrate e to the x squared, which is impossible, or differentiate e to the x squared, which just becomes bigger? And neither of those two make the next piece of the puzzle smaller. If the thing gets uglier, it's probably the wrong method. But a U sub works perfectly. Now, I've seen questions that look like that. What method will you use here? How would you integrate this guy?
How is it integration by parts?
Now it's integration. Make that F and make that G. Do you see what a tiny little change to the question can do to the method that you use? Now, if you do integration by the parts, ... you'll get your answer. Yeah. Do one last one. Let's do the integral from 0 to 9. And the integral, oh, so that's going to be y equals 0 to y equals 9. That should work. And let's do the integral from 0, so that'll be x equals 0 to x equals square root of y. And I don't even care what the function is. we're going to be doing it as a dx dy. So according to this, the y's go from 0 to 9, and the x's go from 0 to the square root of y. Now, if you write x equals the square root of y, if you rearrange that, don't you basically get y equals x squared? So if I sketch this guy, and you could do it in Desmos, it would look like that. And of course, more of it is over here, but I'm not caring too much about that. If you do y equals 0 to y equals 9, and you do x equals 0 to this guy here, right? So let's see if it's the top bit at the bottom. 0, which way are we scanning? We are scanning in y. So y goes from here to here. So we are doing this region. Are you comfortable why I picked the top part and not this little bottom piece? And my argument was, okay, I know it's scanning in the y, so the rectangles go this way, right? If I choose a random rectangle, won't it be 0 to the curve? If it was the bottom piece, wouldn't these two have switched places? So, double integral, let's see what we get. If you now do your scan vertically, that's the new direction, you get x goes from 0 to here, which happens to be 3. And y goes from the curve to there. And so that would be your new orientation. Any questions? Last chance, any questions? Okay, I like that. No questions is okay. And our last thing is we're going to find out how to find the average value of a function. The average value in Calc 2, right? Calc 2 is just the fx world, right? Then the average value of a function is 1 over b minus a, the integral from a to b, there we go, of f of x dx. Can you remember that vague formula? Average value of the function, right? 1 over b minus a, and then an integral. And if you don't remember it, now I've told you, you'll remember it, right? So how do you do it in 2D world? Well, the average value of the function is 1 over the area of d.
Sorry. So this is a case where it is actually a single integral, it's not a double integral?
Yeah. And it's going to be 1 over the area of the region D and the double integral over D of your function f of xy dA. So what we've done is we've basically expanded the idea of an average value to here. So if you're trying to think, what on earth does that look like? Can you imagine that you've got a region in the XY plane, right? This is on the XY plane. And only numbers in the XY plane go vertically upwards and meet the surface. What we're finding is the average height above that surface, right? So could be 12, you know, the average height is 12, some are 8, some are 14, some are 0, some are 40. So the average value is essentially the average height of this function when you only use points in the region D. Now that means we are going to do a lot of integration. And the questions that do average value, I believe, are the last 2 or 3. Check it out, it's the last 2 questions. So question 16 and question 17 are like that. So let me put one. Suppose we have a function f of x, y, and it's equal to x squared plus y. And my region D is basically described as, let's do it this way. 0, 3, cross 1, 2. Now, if you write this notation, doesn't that mean the x's go from 0 to 3 and the y's go from 1 to 2? Now, if I do a little baby sketch of what that looks like, if you do x equals 0 to 3 and you do y equals 1 to 2, aren't we talking that that's the region D? Can you visualize it? Okay, 0 to 3. Now, we need to know, put my formula out of the way, we need to know the area of D. Well, in this case, isn't it just 3 times 1? Can't you do that in your head? You do not need, calculus to do the area of that rectangle. It's just 3 units by 1. Now we're going to do this piece. Well, how about x equals 0 to x equals 3, y equals 1 to y equals 2, and then 1 over the area just gives you that. So it's going to be a third of this integral. The function that we're going to deal with is this guy. I'm going to do dx dy. Could I switch the order of integration here? Could I have done the y's before the x's? In this question, could I switch places? Yeah. I don't think it matters. You could either both equally easy or equally ugly. So what do I get? I get the integral from 1 to 2. If you integrate this with respect to x, you get 1/3 x cubed plus xy, which we evaluate at x equals 0 to x equals 3. And then once you've done that, you can integrate with respect to y. If you plug in 3 here, you get 9. And if you plug in 3 here, you get 9y. And if you plug in zeros, you just don't get anything because they're all 0. And you get that. This becomes, down here. This becomes 9y plus 9 over 2y squared. Still get a third here. Evaluated at 1 and at 2. So that gives me 1/3. You plug in 2, you get 18 plus 18, which is 36. Take away 9 and 4.5, that's 9, 18, 27 halves. And that's 72, hopefully. 72, take away 27. I make it 45 halves. So it's 113. 45 halves, they cancel, and I hope that I haven't screwed up anywhere. The average value of this function over that rectangular region, the average height is about 7.5, right? Some parts of the surface will be much taller than that, some will be much lower, but the average, right? Make sense? Yeah. Let's make that region uglier. So let's suppose I ask for the average value of this function. And the region is described as all the points x, y. Oh, let's do a different one. It's the points from 0, 0 to 0, 2 to 4. So this is the region D, the triangle formed by this, and we're being asked to find the average value. So I'll start by creating the triangle 0, 0, 0, 2, and 2, 4. Right, would you agree that's a much more difficult function to deal with? That area is not just a nice horizontal triangle, it's got problems. So what I'm going to do here is I am going to find the equation of these two lines. So this line here has a slope of 4 and a run of 2, so this is going to be y equals 2x. And this one goes, what does it go? 2 up, and it goes, what, 4 along? Check that. Yeah, this one goes from here to here is 4 along and 2 up. And this one here is 1/2 x plus 2. Can you double check that yourself later? But that's what I believe the equations of those two lines are. Now, in this question, I'm going to generate the region D by using that rectangle. But before I do that and set up, well, I can write that down. I'm going to generate the region D, and then I'm going to, probably I should have done earlier, don't I have to find the area of that triangle as well? But let's, since I said I'm going to do it, x's and y's. Now, if you do it vertically, as I intend to, won't you go from x equals 0 to x equals 2? Right, x equals 0 is here. And as you scan from left to right, you get to there, x equals 2. Now, what will the y's look like? Won't a typical y value start here? That's the low value of y equals 2x. And doesn't it finish up here at 1/2 x plus 2? Are we comfortable about where I got those limits of integration? Okay. Now, subjob. I need to find the area of D. I need to do that, guy, by finding an integral. And that means I'm going to do a calc 2 integral. And I'm going to do the integral from 0 to 2. And same kind of argument, isn't it? Top guy, take away bottom guy. But now it's going to be top function, take away the bottom function, dx. Are you happy what I did there? F of x, take away g of x. You notice that these get put in a different location. So that's going to be the integral from 0 to 2 of 2 take away 3/2 x. And that's going to be 2x take away 3/4 x squared. And that's going to be evaluated at 0 and at 2. Well, when you plug in 2, you get 4. When you plug into, oh, that's a miracle. I wish I'd said I planned this. You get that. Take away a whole load of nothings. Would you believe the area? It was 1. Oh, in a way, that's kind of annoying because won't it look like I'm not doing anything? But isn't it going to be 1/1, right? Can you imagine it was 5, so it'd be 1/5. So you put the package together, and the average value is 1 over the area of D. And the double integral is going to be from x equals 0 to 2. And then it's going to be from y equals 2x to y equals 1/2 x add 2. And then the function is going to be e to the x plus 3y squared dy dx. And that's going to be 1/1, which means nothing at all. It just doesn't affect anything. If you integrate this fella, you're going to get e to the xy. If you integrate this guy, you get y cubed. Evaluated at 2x and at 1/2 x add 2. And this is probably as far as I'm going to take this one. You are going to get 1/2 x add 2 e to the x plus 1/2 x plus 2 cubed. Take away 2x e to the x plus 2x cubed. Dot, 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 dot. Can you imagine what you would do next would be to FOIL all this out, collect like terms, and then just integrate what you've got. Looking at what's happening here, I would probably end up having to do it in 2 separate chunks. Part of this integral is going to have e to the x's times x's in it, which would be integration by parts. And the rest of it is just going to be polynomials, which I would do with the power rule. And that would certainly be a 10-minute plus job. Are we good on how you would finish that if you had the time? Any questions?
That makes sense.
Oh, I like that. That makes sense. That makes sense. Makes me happy. I'm going to do a version of 17 because that last one got really ugly because I made it up on the spur of the moment. Normally homework questions tend to be nicer. So we are going to find the average value of this function. And the information that we're given is that y equals 0, y equals x squared, and the x equals 1. So I'm going to go right in and figure out what does this region look like, because that will also help me decide how I'm going to tackle it. There is y equals x squared. Y equals 0 is the x-axis, and x equals 1 goes there. Is there anything else I need? I'm assuming, yeah, it makes sense. I think it's sensible to assume that that's D. Would you agree? I was just wondering if they could have told me somewhere. Now, there are 2 ways to do this. Couldn't I do it as a vertical cut or a horizontal cut, right? Agreed? If you choose the wrong direction, because there is a 50-50 chance and sometimes you choose the wrong direction. If you did decide to go the other way, wouldn't you be using a square root of y guy? I'm pretty sure that's not going to end well. So I think it's a good idea just to use these guys. So since I've committed to doing it that way, it means I'm committed to doing horizontal. And so it goes from here to here, which is 1. So I'm going to do the limits of integration of the x's. And the limit of integration of the y's, well, any rectangular strip starts at 0 and finishes at the curve. Would you agree that's a pretty nice kind of limits integration, nothing too ugly going on? Now I need to find the area of D. In this case, won't it just be the integral from 0 to 1 of x squared? So that's 1/3 x cubed evaluated at 0 and at 1, and that ends up being 1/3. Oh, that's easy. So the average value is 1 over the area of D times the double integral. In this case, I'm going to go x from 0 to 1, and I'm going to do y equals 0 to x squared, and I'm going to do 5x sine y. Y is first, x is second. Now I know the area is 1/3, so 1 over the area gets me 3. And this integral, I don't worry about right now. If you integrate 5x sine y, right, 5x sine y, be careful. What do you get when you integrate with respect to y, 5x sine y?
Negative 5x cosine y.
Yes. Isn't it dead easy to get your hats mixed up? And you do a differentiation when you know, because they're very similar looking. Now, in this case, You plug in x squared, you get negative 5x, the cosine of x squared. Take away, plug in 0, negative 5x times the cosine of 0 dx. And what does that look like? Negative 5x cosine of x squared plus, oh, isn't the cosine of 0, 1? So won't that just be negative 5, take away another 5? So basically plus 5x. Are you happy about where that plus 5x came from? Now, what we've really got here is an ugly integral, which I would suggest you do in 2 separate pieces. This piece is easy, isn't it? Just a parallel. What method will I use? And I've run out of time, but what method would I use if I did have time to integrate 5x cosine x squared? And be careful.
That would be a u sub.
Yes. And won't the u sub be x squared? So that's all I can help you with. At this point here, wouldn't you just continue and get 42 or a half or minus 20? Whatever the answer happens to be. Okay. Oh, word of warning. This is going to happen in this question. Nowhere did they mention in any of these questions to round off to 2 decimal places. That means that your answer can and will look something like this. Couldn't you have cosine of 1s in it and 3 times the sine of 1s in it? Right? Because aren't you going to be plugging 1 into a cos x squared or a sine x squared? That is the right answer. Do not turn that into nothing 0.1234 because it looks ugly. Right? Just a word of warning. Rose, I think you had your hand up, but I may have just answered the question.
Yeah, you just answered my question. I thought, well, you could just plug that into your calculator and get an ugly answer, but then it wouldn't be exact.
Yeah, so the rule is only do decimal places when the question specifically says to 2 decimal places, right? If it says something like that, then you know you're good to go. They pretty much never do that much, right? Occasionally I've seen them do it, but it's pretty rare. So you're always going to sometimes end up with really ugly answers. And we are finished. Your test will be available in about an hour if you want to. I would wait until Sunday so you're more prepared for it. And say your last name and bye-bye.
Bye. Have a good weekend.
Okay,
Thank you.
You're welcome. I'll hang about for a few if there's any last minute questions.
I had a question.
Yes, what you got for me, Tessa?
This is from the last weekend's homework.
Sure. Have you got it handy?
I'm looking for it right now.
Okay.
Oh boy. I didn't know if we'd have time for questions.
That's
so
fine.
I'm prepared to ask.
I can look in the section. Can you tell me what section it was in?
No,
No.
I think it was 14.8.
Okay, so Lagrange multipliers was the lambdas in it.
Yeah.
Okay. I got that. Have you any rough idea of what it looked like?
Yes, it was 14.8, number 7.
Okay. I've got a version of 7. Let's have a look at it. Yours might be different. Okay, so what is your function f x, y, z look like?
X squared plus y squared plus z squared.
Good, so does mine. And the restriction?
X squared plus y squared plus z squared plus xy equals 27.
Okay, that's probably not going to end well. So we are going to differentiate this guy with respect to x, with respect to y, and also with respect to z. So we have to, do a 3-dimensional grad instead of that. Now, all of these have to be 0. And the only way that is going to happen is at the point 0, 0, 0. So that is a possible critical number, right? That's a place where it might work. Would you agree that if you look at this restriction up here, that if you make x, y, and 0 all 0, it doesn't equal 27? So that means I can't use it. Now, if they had less than or equal to 27, right? Because sometimes they do that, right? If they said less than or equal to 27, wouldn't that be one of the places I could look for a max and a min, right? So are you happy about why that one was kicked out?
Right, yes.
Right. So now we're going to do the gradient of f is lambda times the gradient of g. And g is basically that mess. You actually, once you've done enough of them, can't you pretend that 27 is not there because it's not going to change anything. So if I do the gradient, I have a 2x, a 2y, and a 2z, and it's going to be a lambda. It looks like a 2x plus a y,
Mhm.
and then a 2y plus an x, and then lastly, just a 2z. Be comfortable with that?
Mhm.
And these generate, I'll put it over here because I need more room, some equations. One of them looks like, well, I'm going to put a lambda in front of it, 2x plus y, call that equation 1. And the second one, put a lambda at the front, is 2y plus x. And the third one is just got a lambda. And for consistency, I'll do that. So what we now do is we do a special case of lambda equals 0. And if you do lambda equals 0, don't you actually end up with 2x being 0, 2y being 0, and 2z being 0? In which case x, y, and z are the origin. So guess what? That generates the origin, but isn't that, by coincidence, a guy you can't use again?
Mhm.
For the same reason you could use it here. And then you can do equation 1 divided by equation 2. So you take equation 1, equation 2, equation 1. I might run short of room here, but at least I'll take it as far as I can. You got this one. Now, if you do a little bit of cancelling, the lambdas disappear. If I do some cross multiplying, I get 2xy plus y squared is equal to 2xy plus x squared, which means that y squared equals x squared. You agree that's quite useful to know?
Yes.
Because that means that y is x and y is negative x. You see, we have a way of connecting those two.
Yes.
We're good? Now, if you take equation 1 and equation 3, you get 2x over 2z equals lambda 2x plus y over lambda 2z. And that simplifies down as x over z is 2x plus y over 2z squared. Not 2z, sorry. Are we good with that?
Uh-huh.
Right, now if I cross multiply that, I get 2xz is equal to, that guy is 2xz plus yz. Let's check that, 2xz, 2xz plus yz, and they cancel out, so, that tells me that I can have a z equals 0, right? Or I can have a y equals 0, right?
Yeah.
And the other two can be what they want to be. Now, I'll keep that with the little box around it. Now, there's one more combination I have not done yet, and that's the 2y, right? Equation 2 over equation 3. So we need to do it like 3 times because there's 3 variables. And I am really moving here.
I think it boils down to 0 equals xz. So x could be 0 and z could be 0.
Right. So what we are looking at is a combination of all the things that could happen. Now, according to what I've got here, there should be a possibility of getting something out of this. So all I need to do is go back to the restriction, which was x squared plus y squared plus z squared plus xy equals 27. And the way these combinations come out, can't we get away with any two of them being 0? So suppose I do that combination. Then won't z squared be 27? So that tells me z could be plus or minus the square root of 27. So 0, 0, positive 27, and 0, 0, negative the square root of 27. Now,
Uh,
if I do another combination and say make x 0 and z 0, right? If I do that one and you make x 0 and z 0, I believe you get y squared is 27, in which case y is the plus or minus square root of 27. And so that generates the square root of 27 in the middle, one positive and one negative. And I believe if you go through the third one, you're going to get those guys. And that one should be a 0, by the way. So do you see there's 6 places to go hunting?
yes. Okay.
And go hunting for the biggest and go hunting for the smallest.